So another way to solve quadratics algebraically is by factoring. Well, like I said, there's several different factoring methods. One is if there's a binomial, which means that there's 2 terms in the original problem. And one is if there's a trinomial, which means 3 terms. Either case, the very first step you should think of is the same for both, GCF. And remember that if you do a GCF problem, you're going to end up with one set of parentheses. And both of these say the same thing. You're going to pull your GCF out in front of the parenthesis and then divide each term by that GCF and put that inside the parentheses. So I'll kind of go slow here. So if I gave you, I'll give you a trinomial because it works the same. If I gave you 4x squared plus 3x, I don't want 3, let's do 12, plus 16. Okay, it's a trinomial here. Now, is there something that you can divide all 3 of these or everything by? Yes. So your GCF will be whatever you can divide them all by. In this case, you can divide them all by 4. So we're going to put the GCF out in front, and we're going to make one set of parentheses as wide as the original problem. And then what you're going to do is you're going to either write this down. This is what I used to teach in Algebra 1. I had them actually write it down. But now that you're in Algebra 2, you can probably get away from that and just do it in your head. What is 4x squared divided by 4? Just x squared. What's 12x divided by 4? And then 16 divided by 4. So that's how you do a GCF problem, whether it's a binomial or a trinomial. You want to pull your GCF out, make one parenthesis, divide by your GCF, and see what's left over. Alright, now, let me just put the title up here. These are for binomials, and these are for trinomials. Once we get beyond the GCF stage, then you go into a different mindset. Okay, so if it's a binomial and it's a perfect square binomial, you're going to end up with 2 sets of parentheses, but the original problem must have a subtraction sign. So let's take a look at this. So here's a binomial, okay, but it's not a perfect square binomial because both of these aren't perfect squares, so that won't work. Okay, that's a binomial. These are both perfect squares because there's an imaginary 1 there, but that has a plus sign. So it has to be a binomial, they have to be perfect squares, and there must be a subtraction sign. So let's look at this. Okay, that will work. So you have to recognize when it will work. So you're going to end up with 2 sets of parentheses. And what you're going to do is you're going to take the square root of this, which will give us 2x. And since it's at the beginning of the problem, you're going to have the identical things in the beginning. This minus sign is going to turn into a plus and a minus. And then what's the square root of 9? There you go. And now you can always check and see if you're right by distributing back out. If you distribute those back out, you'll end up with this. But this is what we call the factored answer. Now what about trinomial, perfect square? So trinomial means I'm going to have 3 of them. We will eventually end up with 2 sets of parentheses like we just did. But here's some more stipulations, a couple here. So if I give you this, x squared minus x minus 6, okay? Is it trinomial? Yep. Now, is the first and the third term a perfect square? No. So I couldn't do this by the square root method, or sorry, the perfect square method. So I need to do a perfect square method. How about this? Okay, is the first and the last a perfect square? Yep. Now, what I'm going to do is I'm going to make my 2 parentheses. I'm going to take the square root of the first, which gives us x and x. It says and the third, so what's the square root of 9? 3 and 3. Notice I put 3 and 3 at the end because 9 is at the end. Now in this case, I need to use the same signs. I'm either going to use 2 pluses or I'm going to use 2 minuses. So in order to figure that out, just look at the sign of the middle term right here. And then the same thing as the last one. Double check it to make sure it's right. Distribute that out and see if you get x squared plus 6x plus 9. Alright, so what if they're not perfect squares? And then we run into a third type of problem, but only exists with trinomials, not binomials anymore. Alright, so what if I try the one that we said we couldn't do here? Okay, I can't, there's no GCF and I can't do it by perfect square, so I'm just going to look at it this way. The difference between these two is that this has a number out in front. This is imaginary 1. So this goes along here. Okay, so what I'm going to do is I'm going to make 2 sets of parentheses. That's what this is saying. And you got to come up with numbers that multiply to give you the number at the end and add up to the number in the middle. Some teachers will do it this way. The number at the end, let's figure out what numbers will multiply to give us the number at the end and add up to the number in the middle. And the number in the middle is -1. Now, in the meantime, while you're thinking of that, notice how this says x and x? Because that's x squared, we're going to break that down to x and x. Now, have you come up with the numbers yet? What numbers multiply to give us -6 and add up to -1? So we've got -3 and +2. Double check. Do these multiply? Yep. And if I add these, will it give me -1? So I'm going to put -3 and +2. And that's how I factor this one. Sometimes I'll call that the easy method because there's really no special words to it. You just got to come up with the numbers at the end and middle. Now, very similar to that, let's throw in a number out in front. 2x squared minus 11x plus 12. Okay, and some teachers teach magic number different ways. Some people do like little sets of parentheses. I'll talk about them both, but then I usually stick to the star method. Okay, your magic number is the number out in front. But we don't try magic number unless we've tried all the other methods. Okay, so what we're going to do is we're going to multiply the front number, which is the magic number, by the end number. So what is 2 times 12? 24. So now I'm going to make my cross like I did earlier, except for now I'm going to make it into a star. I'm going to draw an extra line there. So 2 times 12 is 24. So now I'm thinking of all the numbers that multiply to give me 24 and still add up to the middle number. Have you thought of them? -8 and -3 should work. These add up to -11, and these two multiply to give you 24. Make sure you put them in the bottom side pouches. Now this magic number right here is going to go in these leftover spots, but not x squared because we've got to split it. So we're going to do 2x, 2x. The x and x get split from x squared. The 2, we're going to start with them in both, but we're not going to end in both. So once you get the star set up, we don't really care about these anymore because that was just used to help us set it up. Now, can I reduce that? What can I divide them both by? Yep, I can divide them both by 2. So then that will give me x minus 4. And then can I divide both of these by something? Nope. So that's going to leave it 2x minus 3. So when you do the magic number, you're not going to get just the letter and just the letter, just the variable and just the variable. You're going to end up with an extra number or 2. Depends on the actual problem. So in this one, I would call this the easy method because there is no GCF, there's no perfect squares. So what numbers will multiply and add? Multiply and add. So +5 and -2, right? So then I'm going to write x +5 and then x -2. Okay, how about these ones over here? So what we're going to do is we're going to, okay, look at this. It's an easy method again. What numbers will multiply to give me 35 and add up to 12? Have you thought of them yet? 7 and 5. So we're going to go x plus 7 and x plus 5. Okay, this is a binomial. So if it's a binomial, you can't do that little star or the cross method. So we're going to look for GCF. I can pull an x out, and that will leave me with x minus 8. Ooh, see this number out in front? That's a magic number problem. So the 3x squared, I'm going to write 3x and 3x right now. I'm going to multiply the 3 by here, and I'm going to write -6 here. So -6 up top, -5. So let's think. Multiplication and addition. Have you figured them out yet? -6 and +1 will add up to -5 and multiply for -6. Now can I reduce these? I can divide them both by 3. So it'll give me x minus 2. And then how about these? Can I reduce these? Nope. 3x plus 1. So if you haven't figured it out yet, we haven't solved anything. Okay, all we've done is factor it. So now let's take it that one step further and solve. Now remember we said we're going to use the zero product property. Since both of these multiply together to equal 0, I'm going to assume that either one of them could equal 0 by themselves. So add 2, subtract 5. There's my two answers. Same thing here, since both of these multiply together to equal 0, x plus 7 could be 0, x plus 5 could be 0. So this solution is -5, and this solution is -7. Same thing here, x minus 2 equals 0, 3x plus 1 equals 0. So I'm going to add 2 to get rid of the minus 2. Notice on this one I got to subtract 1 first, and then divide by my coefficient. So my answer is going to be -1/3. Notice on this one it's not a parenthesis, it's just x, so we're just going to write x equals 0 and x minus 8 equals 0. So that there's no solving to do here, it's going to be 0. And this one we can still solve though. So with factoring, you want to factor and then set each factor equal to 0 and solve. And this one though, says it doesn't have everything on one side equals 0, so you've got to make it equal 0. So let's add 49. Alright, now I'm going to look for GCF. Can I divide everything by something? By the same number? Nope. It's a trinomial. So are there perfect squares at the beginning and at the end? Yes. So I'm going to totally ignore this for now. I just want to look at these. So let's try it that way. Square root of that is 2x. Square root of 49 is 7. And because it's a trinomial, I have to use 2 pluses or 2 minuses. Which one do you think it is? Now we look at the middle term and say, wait, there's a plus there, so they probably should be pluses. Now, how do I know if I'm right? Notice how I totally ignored 28. Now this is where that comes back into play. Let's check this. Let's go ahead and distribute these two parentheses out. That will give me 4x squared and 14x. Another 14x. 7 times 7 is 49. If I add those together, I'm going to get 28x in the middle. Will that work? Was that what I started with back up here after I put it all on one side?